What is the one fact about the universe that blows your mind the most?
There are a lot of things about the universe that I find it almost impossible to imagine. Well, actually impossible to imagine. One's just the size and scale of it. I mean, in the piece of the universe we can see, there are something like, roughly, 2 trillion galaxies. We haven't counted them all, but that's an estimate based on surveys of the local universe. 2 trillion, 2,000 billion galaxies. And each galaxy is, let's say, around the size of the Milky Way. Some are bigger, some are smaller, but the Milky Way has 400 billion stars in it. It takes light over 100,000 years to cross a galaxy. And there are 2 trillion of them in the piece of the universe we can see. And we're very sure that that piece that we can see is a small bit of what may be an infinite universe beyond. We don't know, actually. And I always say, don't get worried about that, because nobody can picture it. It is impossible to visualize the scale of the universe. So that's the first thing. I could then list a lot of more things, but we'll stop there for now. But just the size and scale of it, I think, is beyond imagination.
There's been a lot of references to the multiverse and parallel universe in popular culture lately. Do you think that something like this is a possibility?
So there are lots of multiverses, actually, in physics. One of them is called the inflationary multiverse, which is we have a theory of essentially what happened before the Big Bang. Right? You have to be careful with the language. So if you define the Big Bang really carefully as the time when the universe was very hot and very dense, and as I said, you can't argue with that because we can see it, because we can look out into the sky. Our best theory of how the universe got into that state is that there was a time before that, and it's called inflation. So the idea is the universe was there, in a sense, cold and empty and expanding extremely fast. And that expansion slowed down and stopped. And the energy that was driving that expansion got dumped into space, heated it up, and made all the particles out of which we're made. And that's what we call the Big Bang. So that's textbook. It's a textbook theory called inflation. It made predictions, some of which have been tested. Some incredible predictions, actually, about the way that galaxies are distributed across the sky, because they're not just random. If you look at the galaxies, they're in sort of flows and rivers of galaxies that cross the sky in a pattern called the cosmic web. And inflation predicted that before it was seen, actually. So it's an astonishing idea. And that theory has a kind of an extension called eternal inflation, which is that the inflation essentially goes on forever. And it just stops in little patches. So you imagine the fabric of the universe, space-time, stretch, stretch, stretch. And then it slows down and stops in little patches. And each one of those patches is basically a Big Bang and a universe, of which ours is one. So you end up with this sort of picture of an infinite fractal universe of basically an infinite number of Big Bangs. And that's called the inflationary multiverse. And it answers some neat questions, because if you say, why is our universe the way that it is? Why are the laws of nature such that life can exist, for example? Well, the answer might be that all possible combinations of all the laws of nature exist in the inflationary multiverse. So then it's not surprising there are universes that permits things like us to exist, because every possible universe exists in the inflationary multiverse. And that's a well-supported theory. It's a theory, so this is not the same as saying there was a Big Bang, which we know. This is kind of, what's a theory? It's a guess, basically. But it is a theory that in its simplest form has made predictions that have subsequently been verified. And we could go on then. There's the so-called many worlds interpretation of quantum mechanics, which is more kind of Marvel film kind of multiverse, where so quantum mechanics it's a probabilistic theory. So imagine a quantum coin, I call it. And the quantum coin it doesn't have to be heads or tails, it can be heads and tails. So it can be mixed up, it can be both heads and tails at the same time. You may have heard of Schrodinger's cat, which is a cat in a box, and it's both alive and dead until you observe it or interact with it in some way, and then you find out which one it is. But before you looked at it, or before you interacted with it, it was both.
You've talked about the number of galaxies. Does any of this ever make you feel insignificant?
Yeah, I mean, so I say sometimes in my live shows, it's kind of a joke, right? So I'm not insulting philosophers here, but I say there's only one interesting question in philosophy, right? And I don't really mean it, but I think it sounds funny. So the interesting question is, what does it mean to live a finite, fragile life in an infinite, eternal universe? So that's not that funny, right? It's a good question. What does it mean to live a finite, fragile life in an infinite, eternal universe? And I think the answer is that, sort of paradoxically, whilst we are definitely physically insignificant, I've just said, that the Earth is one star around one, the Earth is one planet around one star amongst 400 billion stars in one galaxy amongst 2 trillion galaxies in a small patch of the universe, right? So we're definitely small, and you can't argue with that. We're just specks of dust. But if you think about what we are, so everybody, me and you, everybody, we're just collections of atoms, right? Some of them are as old as time, pretty much, and some of them were the other ones. Everything else, other than the hydrogen in our bodies, was made in stars, right? So we're all cooked over billions of years, and we're in this pattern that can think. So suddenly, as the great Carl Sagan said, you have a means by which the universe understands and explores itself, which is us, and that sounds unlikely when you put it like that, that you can have a few things that were cooked in the hearts of stars, you stick them together in a pattern, and suddenly it has some ideas and starts writing music and art and things. That's quite difficult to comprehend, right? But that happened here. We know that because we're sat here having a conversation. And so the question then becomes, well, on how many other worlds did that happen? And that's where I think the value can come in, because it's a reasonable guess, and it's just a guess, right? But it's reasonable. You can make the argument that there aren't any other worlds where this happened, certainly in our galaxy. So it could be that this planet, notwithstanding its physical insignificance, is the only place where anything thinks, right? For millions of light years in every direction. And suddenly, therefore, you end up considering this planet as being the most valuable place in the local universe, notwithstanding the fact that it's small. And that idea, it's not just a complete random guess, by the way. We've had a bit of a look. Astronomers have pointed radio telescopes up at the stars for a while, 50 years or more now, and heard nothing. We've seen no evidence of any civilizations out there beyond Earth, and that's a surprise. There's a reasonably plausible explanation for that, which is biology, which is that if you look at the history of life on Earth, then you see that life began pretty much as soon as it could here on Earth. We have evidence there was life 3.8 billion years ago, something like that. And the Earth's 4.5 billion years old. So pretty quick in geological time, you get life. But then if you talk about advanced life, complex life, multicellular life, then there's no evidence at all back beyond a billion years. Actually, really, in the fossil record, 650 million years ago or something, you start seeing the first evidence of complex creatures. So that means that on this planet, it took over 3 billion years to go from a single cell life to anything more complex than a single cell. And then another 500 million years or so to go from the multicellular things to a civilization. So it's 3.5 to 4 billion years. It's a third of the age of the universe. That is a really long time. If you say, that's an unbroken chain of life on a little piece of rock in a violent universe, and that chain was not cut for 4 billion years in order to get us. And that might be a big ask, right? We live in a really violent universe. You look at the Milky Way and you look at that arc of stars across the sky, 400 billion suns. All there will be up there at best is slime. It's just slime. Nothing, right? And I think that's a reasonable guess. That's where I start from. I mean, I wouldn't be surprised if that's wrong. Then you go, okay, good, well, fine. But at the moment, it looks like there isn't anything else other than slime. We haven't even discovered slime, by the way, yet. We're still in the position where we've not seen anything, not even a single cell on Mars or the moons of Jupiter or somewhere like that. So at the moment, we are alone, as far as we can tell.